A comprehensive study of the acoustic properties of metal meshed reinforced sustainable foam. Abstract organic foam with copper, brass, iron, and steel mesh reinforcement are prepared. Acoustic shielding test, yielding sound absorption coefficient of the samples is performed. The reinforced samples showed better result than normal foam, especially in lower frequency range. Foam with brass and steel mesh reinforcement showed the best sound absorption capability among all of the samples at the lower frequency of 200 to 250 Hz. The SEM result testified that the holes in the reinforced samples are discontinuous, causing energy loss of the sound wave and thus imparting better sound absorption capabilities to them. Keywords: acoustic shielding, frequency range, sustainable flexible foam, sound absorption capability, SEM analysis. 1. Introduction. In today's era, noise is among the most pressuring issues of our society. Any unwanted and excess sound around us is called noise. If the level of noise can be reduced, it can become an application of high significance. Hearing loss is just a singular problem of these outlandish disturbance levels. It can intrude in day-to-day life and can cause trouble and non-sound related issues. 1 to 3. Adding to it, if present in huge degrees, it can lead to essential dysfunctioning and degradation in life of mechanical equipments. For example, in case of control valves, the vibration due to the irregular flow of stream can cause hindrance with the feedback system of the control unit and can result in severe oscillations. The need for reduction in noise and vibration level could be clearly realized by looking at rules that have been laid by governments to restrain disturbance created by this. The present-day contraption, air/surface transportation, and improvement practices are believed to be the standard supporters of upheaval creation or assumed uproar tainting for. Right now, lightweight and pocket-friendly composite materials that will acclimatize sound waves in increasingly broad frequency range are essentially needed. In the current scenario, by a wide margin, a large portion of acoustic material is conveyed using produced strands which are risky to human health. Condition 5. Thus a eco-friendly material is needed and common foam can be one such solution. In this research paper, organic foam is developed and analyzed for its acoustic characteristic. The advantages of using regular foam are that it is low-density material, versatile and hazard-free. We have used various tests to various properties of the material. With the help of acoustic ensuring test setup, acoustic securing limit of the material was calculated. Earth-wide temperature support is another huge issue with racket defilement. Right now, is an essential of an adaptable material which has an extraordinary sound ingestion coefficient, just as is an awful conductor of warmth, so it shields a bound space from upheaval just as from warmed outside. PU foam is a heat insulator. 7. Regardless of way that PU froths, it has sufficient quality. 8. For the present applications, its quality can be regulated by layering of mesh with different materials and number of layers. The fabricated material can be used for applications varying from sound insurance material for dividers of structures or vehicles to internal securing material of planes and space transports. We can achieve maximum absorption at resonance over the broadest possible range by measuring specific acoustic impedance in an impedance tube 9, 10, 11. In this experiment, 5 samples are fabricated, 1 among which is an organic foam without additives, and 4 are flexible foams with different mesh material incorporated in it as a filler layer. Even after having various properties, the gathering cost of the material is humble and manufacturing is simple and fast. With its non-hazardous nature, versatility, and reasonable cost, it is a great material with an astoundingly colossal extent of uses. 2. Experimental procedure. A. Fabrication of meshed foams. 5 samples are fabricated, 1 among them is a sustainable organic foam without mesh reinforcement, other 4 sustainable organic foam with different mesh samples have been prepared with single layer of copper, brass, iron, and steel meshes of grid size 1 mm reinforced in flexible foam. Wooden and aluminium boxes with top side open are made to carry out the foam forming reaction. The boxes are mounted with fixtures to hold the mesh in the middle of the foam. Once the mesh is fixed in the mold, a blend of isocyanides and synthetic polyol are mixed together in a ratio of 2:3. The nature of the reaction is exothermic with release of CO2 fumes as shown in Fig 1, 2, 3 respectively. 12. C. Steel, D. Iron. Fig 3. Metal mesh is reinforced in foam. B. Experimental analysis of acoustic shielding of different materials setup. Sound absorption coefficient can be defined as some part of energy of sound absorbed in a given frequency band by the sample incident with a sound wave. It indicates the capability of the sample to absorb the sound over a given range of frequency bandwidth. Impedance tube apparatus is used for measuring the sound absorbing capacity of a material. The characterizing system consists of a solid glass tube in which a speaker is embedded at one end and the sample is held inside a cylindrical vessel at the opposite side as shown in Fig 4. The framework likewise has a couple of sound receivers that are connected to the digital signal analyzer via preamplifiers and a DAQ. It's powered by a function generator and also has a rigid backing. The specifications and schematics are shown below in Fig 5, 6, 7, 8 and Table 1 respectively. 11. Fig 7. Sample in the impedance tube. Fig 8. Spectrum analyzer. Table 1. Technical specifications of impedance tube apparatus. Parameter specification. Impedance tube length 900 mm. Inside diameter 56 mm. Speaker frequency response range 160 to 7000 Hz. Signal generator 200 to 6500 Hz. Sweep-in automated. Number of microphones 2. Sample holding unit 50 mm. Controls PC automated measurements. Software MATLAB. 3 results and decision. AFTIR characterization. As indicated in the below graph from the Fourier transformation infrared, FTIR, spectrum, we can easily characterize the presence of different functional groups present in the sample. The plot obtained is shown in Figure 9. Flexible foam. In the following graph below, we can see that Broadens occurs in the range near 3500 cm1, which indicates the presence of O functional group. Also the peak sharply stretches in range 3000 cm1, which indicates the presence of CH group. Moreover, the absorption ranging between 2165 to 2110 cm1 shows the indication of cyanide functional CN group. B. Experimental analysis of acoustic shielding of different materials. Result obtained from the acoustic shielding test is represented in the form of a graph as shown in Figure 10 and has also been summarized in Table 2. It is found that the mesh reinforced foam shows better sound absorption coefficient than the normal foam. We observed improvement in the sound absorption coefficient after reinforcement, especially in the lower range of frequency. Table 2. Test observations of sound absorption coefficient. See scanning electron microscopy analysis. Above figures 11,12 were obtained from SEM analysis of the foam. It was found that there are more discontinuous holes in the mesh reinforced samples than normal foam. This discontinuity causes energy loss in the sound wave, making sound absorption coefficient more for the reinforced foam. For conclusion, the capability of sound absorption by the material is characterized using the acoustic shielding performance test, and FTIR test is used to characterize the chemical structure of the sample. It was found that the mesh reinforced samples showed better sound absorption coefficient than the normal foam, especially in low frequency range. Sample with brass mesh showed the best sound absorbing among all the samples in the frequency range of 200 to 250 Hz. The SEM pictures showed that the holes in the reinforced foam were more discontinuous than the normal foam, thus enhancing loss of energy in the sound waves and making them more effective in sound absorption. Due to reinforcement of the foam, its shape retaining ability and strength increased, thus making it more prominent candidate in the use of real-life applications. Nomenclature. S. PU foam with steel mesh reinforcement. C. PU foam with copper mesh reinforcement. I. PU foam with iron mesh reinforcement. B. PU foam with brass mesh reinforcement. N. PU foam with no reinforcement.